This is a video showing how to do some automated measurements or time temperature studies with the Zetasizer Nano series software. So the tool that we'll be using for this is in Measure, and it's the SOP Player. So within the SOP Player, we can actually set up the instrument to run multiple SOPs back to back on the same sample. Of course, you don't have a way of changing the sample automatically unless you have one of our accessories such as the Nano Sampler or the Titrator. But this would be how you could take a sample and maybe you want to do a time study or temperature study on it, and you can basically set it up, walk away from the instrument, come back, and have all of the data collected. So the first thing you will need to do is you'll need to have some SOPs to put into this. And so I'll first go out of this and we'll just make some SOPs together. So if I go into Measure and Manual, I can write an SOP. So I'm going to write a quick one for sizing here, just to show you what it would look like. I'm going to leave the sample name blank here and enter in some information. I'm not going to be concerned about the volume distribution, so I'm just going to leave the material refractive index blank and just use the intensity data. The dispersant, let's say I'm working in water. The temperature, I'd like that to start at least at 25 C for my study. And equilibration time. So remember, in the SOP, every time, like if I loop this SOP, it's going to run through all the settings in it. So if I don't want that to happen, I can just put that as 0. I'm going to do actually an SOP where I do size and then zeta potential and then size measurement and then zeta potential. So I'm going to select a cell that's capable of doing that. So this is the disposable folded capillary cell, and that one we can make sizing measurements in and also do zeta potential measurements in. So I'm going to select that. And I'm going to do triplicate measurements at each time point. So I'm going to put 3 in here for the number of measurements and use our general purpose algorithm. So I'm going to go ahead and save that somewhere. So size testing is what I'm going to call it. Now I'm going to write one for zeta potential, since I'm going to do size zeta potential. And again, let's put in my dispersant is water. This is the appropriate model for water that I'd like to do to convert electrophoretic mobility to zeta potential. The temperature, again, I'll match the temperature, and I'm going to put this 0 equilibration time in there. And then this is the appropriate cell that I've selected in the first measurement. I'd also like to do triplicate measurements here, but I think that I'd like to maybe put like a little bit of delay in between the measurements, just to give the sample a rest. And I'll use this on auto mode because I would like to measure both the average zeta potential and also zeta potential distribution. If you just want to measure just mean zeta potential, you can do this monomodal measurement if you like as well. So I'm going to save that. We'll call that zeta testing. Okay, so now we have our SOPs saved. Okay, so now we can go back to our SOP player, and now we can start adding in our SOPs. So the very first thing I need to do is probably set the temperature in the instrument and have my little equilibration time, at least maybe for the first measurement, since I didn't do that in my SOP. And you can skip this step if you don't want to do that, that's okay as well. So what I'm going to show you how is to set the temperature. So if I set this to an absolute temperature and put in 25 C, then you see that it says temperature change. We're changing this to 25 degrees C. Okay. And now I would like to put in a pause. Maybe this will be effectively my equilibration before my first sample even starts. And yeah, I put in 60 seconds here. Now I think I'd like to do my size measurement. So I can go in my size testing and load that up. Now here's where it gives me the place to measure my put in my sample name. So I'll put this sample 1. This is my sample, and you see that it will run that. Now I'd like to do a zeta potential measurement, so I'll go find my zeta potential measurement here and open that up and give it a sample name. And now I have my series here. Now I could copy and paste this multiple times to make sure, let's say I don't want to go through this equilibration step again, and maybe I just want to do these two steps multiple times. I could keep copying and pasting that. Or let's say I just want to loop this whole series. So I'm going to take these back off. If you go see this number down in the bottom, it'll actually loop through all of these for you. So let's say I want to do 10 runs and I want to do each of these steps every single time. So I'm going to set the temperature to 25°, pause for 60 seconds, make my sizing measurement, make my zeta potential measurement, set it again to 25°. It shouldn't have changed either way, and then continue making the measurement, and then do that 10 times. So really you can customize this however you like. Another thing you could do is, okay, maybe I want to do a time study. So maybe I want to do size, zeta potential, and then I want to pause my playlist for a significant amount of time. And this is in seconds. Pause, wait, and then go back and do another sizing and zeta potential measurement and continue on. And then you could loop that multiple times as well. If you want to do temperature increments, you can do that as well. So we're going to delete that off and say I'm going to do size measurement, do the zeta potential measurement. Now I started at 25°. And I'm going to increase the temperature, I don't know, 1 degree, let's say. And then I'd like to loop that a couple times. You just have to be careful because you don't want to go over the temperature for the specific cells. So all the zeta potential cells, the disposable folded capillary cell, you cannot use them over 70°. So anything below that is okay. If you're using a sizing cuvette and it's a polystyrene cuvette, just make sure that you don't go too high in temperature, obviously, because you wouldn't want to melt the cuvette. So you have to be a little bit careful with designing those types of experiments here. But this is how you would use the SOP player to make some measurements and then be able to set up some measurements and be able to walk away from the instrument, come back, have all your data. And so if you wanted to just start, you would go ahead and press play, and then you would save your playlist so you could come back and use this again. And it would start the sequence of events.